Okay, today we're going to be talking about two other trig functions. Yesterday you guys learned tangent. Today we're going to learn sine and cosine. So I want to go over labeling the right triangle again. So remember this little symbol right here is theta. And you want to label the one directly across from the right angle, that's the hypotenuse. And the side directly next to theta, that's the adjacent side. And the side across from it or away from it, that's your opposite side. So the ratio for sine is sine of theta equals opposite over hypotenuse. And cosine of theta is the adjacent side over hypotenuse. So they're pretty similar, just the only difference is the opposite and the adjacent. So we're gonna go over sine first. So just like yesterday, the first thing you always wanna do is label your triangle so you know what's where. So this is our hypotenuse. And this is our theta, and since x is away from theta, we know this is our opposite side. So we're gonna set it up sine of 60 is equal to whatever your opposite side is, which in this case is x, over your hypotenuse, which is 18. And so you're solving it just like how we did yesterday with tangent. So this is technically over a 1. Then you just cross multiply. So you have 18 sine of 60 equals x. And since x is by itself, then I could put it in the calculator. So type it in just like you see it. And then you're gonna round it to the nearest tenth. So since it's 0.58, we'll say x equals 15.6. So number 2, same thing. So this one we're just practicing with sine just so you can get used to it. So again, directly across from the right angle, that's your hypotenuse. And the side away from theta, that's our opposite. So you have sine of 68 is equal to your opposite, which is x in this case, over 11. So now that you have it set up, cross multiply. And since the variable is by itself, then you can type it in. And so x would equal about 10.2. And number 3, so you're gonna do the same thing. Label your triangle. X is our hypotenuse. And since 13 is away from 47, this is our opposite. So we have sine of 47 equal to our opposite, which in this case is 13, over x. And then cross multiply. Now you have x times sine of 47 equals 13. So I can't type this in my calculator yet because I don't have x by itself. So since x is being multiplied with sine of 47, you need to do the opposite, which is divide by sine of 47 on both sides. And so now you can type in your calculator 13 divided by sine of 47. So x would equal about 17.8. So that's how you use sine to find a side measurement. And now it says find the indicated angle to the nearest degree. So this is where the inverse comes in, like what we did yesterday with tangent inverse. This is when you're going to do shift on the calculator. So like always, label your triangle first. This is your hypotenuse. And since it's away from theta, this is your opposite side. Now we have sine of theta, because we don't know what it is, equals opposite over hypotenuse. And so the opposite of sine, because I want to get theta alone, that's when you're going to do sine, theta equals sine inverse of 14 over 24. So you want to type that exact thing into your calculator. So to get sine inverse, make sure you press shift sine. You should see that little -1. 14 divided by 24. And then you're going to round it to the nearest whole number. So theta would be about 36 degrees. And so same thing with the next one. This is your hypotenuse. And the side away from where theta should be, that's your opposite. So sine of theta equals opposite, which is 51, over hypotenuse, which is 55. And so same thing like before, whenever you're trying to find theta, you need to do the inverse. So sine inverse 51 over 55. And now you can put that in your calculator. So shift sine 51 divided by 55. And then so it'd be about 68 degrees. And then the last one for sine. So again, we're trying to find theta. One across from the right angle, that's our hypotenuse. And away from theta, that's your opposite. So sine of theta equals opposite over hypotenuse. And so you're going to do the opposite of sine again, which is sine inverse. And then shift sine 24 divided by 34. And then rounding it to the nearest whole number, it'd be about 45 degrees. Okay, so that's sine. So sine's always opposite over hypotenuse. And cosine's kind of similar, except now it's using the adjacent side in the hypotenuse. But the whole process is the same as sine and tangent. So looking at this one, find the missing side, round to the nearest tenth, so same thing. So just like always, label your triangle. So 14 would be the hypotenuse. And then since this side is right next to theta, this is the adjacent side. So now since we're using adjacent and hypotenuse, you have cosine of our theta is 70 equals adjacent, which is x, over hypotenuse, which is 14. So same process, you're cross multiplying to get x alone. So 14 times cosine of 70 equals x. So since x is alone, then I could just go ahead and put it in the calculator. So 14 cosine of 70, and then rounding it would be about 4.8. Then trying this one, same thing. Label the hypotenuse first, because that's always easy to find. So this time x is our hypotenuse. Oops. And 17 is right next to theta, so that's our adjacent side. So we're using cosine of 39 equals adjacent over hypotenuse. And then cross multiply. And so since x isn't alone yet, it still has this cosine of 39. Now you have to divide by cosine of 39 to get it by itself. So this cancels. So you want to put this whole thing in your calculator. And so rounding it give you about 21.9. So then again, for this one, we're still using cosine. So this is our hypotenuse. And 13, that's adjacent to theta. So cosine of your theta, 25, equal to the adjacent over the hypotenuse. So now cross multiply. And so x isn't alone, so I need to divide by cosine of 25. So it'd be about 14.3. So then now going to finding the angle. It's the same thing as sine and tangent, except now you're just using cosine. So across from the right angle, that's your hypotenuse. And right next to theta, that's your adjacent. So we don't know what theta is, that's what we're trying to find. So cosine of theta is equal to adjacent over hypotenuse. And so same thing as before, we have to do the opposite of cosine. So that's why it's cosine inverse of 1731. So just make sure when you put in your calculator, you press shift then cosine. and 17 divided by 31. And so the closest whole number, that'd be 57. Number 11. Yeah, okay. So again, I always do this one first, hypotenuse. And then this side is right next to theta, so it's adjacent. So cosine of theta, because we don't know what it is, equals adjacent over hypotenuse. So same thing, do the opposite of cosine, which is the inverse. And press shift, cosine 13 divided by 19. So our answer would be about 47. So last one. This is the hypotenuse. And the side right next to our angle is the adjacent. So cosine theta, because we don't know what it is. Adjacent, which is 52, over our hypotenuse, which is 56. And again, since we're looking for theta, we have to do the opposite of cosine. So cosine inverse, 52 over 56. So shift cosine, 52 divided by 56. And so rounding it, oh, what just happened? Is that it? Yeah. Okay, so theta is about 22 degrees. So that's sine and cosine. So now you know tangent, sine, and cosine. Hopefully this made sense. I hope. Hopefully I didn't go too fast or something. And sorry my voice is annoying, it's still gone. But then, so for the rest of the period, just work on the back side. Just pay attention up here, because it tells you which function to use. So for 1 through 6, you guys are using sine. For 7 through 12, you're using cosine. And then down here, 13 through 18, you're using tangent. So just pay attention to which function you're supposed to use, or else it'll get confusing. The answers are on the next slide of the slideshow, so make sure those are up there so then you can check as you go, and then just turn it into the tray when you guys are done. So sorry I'm not there again. I'll be there on Monday. So I hope this made sense, and I'll see you soon. Bye.